this week. Start recording. Alright, so today we are working on the wave function collapse thing, and by that I mean I have one more big feature to add to it, plus a few tweaks to existing features, one of which I want to do first. The new big feature is going to be mirroring, and that is mirroring for once you have extracted samples, making mirrored version of those samples, either horizontally or vertically. And I guess you might want to do both. Well, no, if you do one and 180-degree rotation, you get that. So I'll implement both horizontal and vertical flips, but you shouldn't ever do both. You should do 180-degree rotation and then one flip type if that's what you want to do. Volibus, the generator is just for, wait, you mean this wave function collapse generator? Or my site generator that we were talking about before I hit the record button? I'm not using this in anything in particular at the moment. I actually did use a similar technique in a game jam a couple months ago. Throughout October, I worked on, every Saturday I spent a little time working on this game called The Most Undead, and part of what I did there, it's sort of a Tetris style game where you drop blocks, and to make the random sequences of what blocks should come down, I used a one-dimensional wave function sort of algorithm, which I implemented. I didn't copy this one. I made my own, implemented the same technique there. But the point is, this particular code is just sort of my weekly practice code and dog food on 4Coder and stuff like that. I don't think I'll use it for anything right off the bat, although I do have some neat ideas of things I could possibly use it for if I ever wanted to make a roguelike game or something. There are some ways that I could imagine using it. Yeah. Okay. So anyway, Wave 2D image processing params. Check extract samples from image. I see. Okay, so right here is where it applies rotations. And you can see that it always applies rotations 1, 2, and 3, because it does rotation equals 1, and then it goes up to equal less than or equal to 3, and goes through all those. And that's fine, but I don't want that exactly to be how it works. So, here's what I want to do. First, I want to enable controlling which rotations you do. In particular, you should be allowed to do normal and 180. You always get non-rotated. Then you can get asked for non-rotated and 180 degrees, but not the level 1 and not 1 rotation and 3, only 2 rotation, basically. And then you can ask for level 2 rotation, which is it's basically 3 states. No rotations, just the 180-degree rotation, and all possible degrees of 90 rotations. Whatever. I can't quite put the sentence together correctly, but hopefully you know what I'm talking about. So the idea here is just to set up a system where I can specify which rotations to apply in different situations. So if the rotation level is 1, then I will do a rotation array equals rot level 1, and rotation count equals the array count of rot level 1. And similarly, here we get 2 and 2. I don't have an assert, so that's kind of weird. Do I really not have an assert? Okay. Okay, then let's just do it this way. Alright, so now what we're doing is we're saying here are the two ways, like the two patterns of rotation we might want to apply. Here are the variables we're going to use to sort of represent the rotation pattern once we've decided what the rotation pattern is. And then we decide what the rotation pattern is, put the result in those variables, and then right here we're going to do rotation index equals 0 for rotation index less than rotation count. Then we increment the rotation index, and then I'll pull out the rotation from rotation array rotation index. Alright, so that's basically the same as it was before, except now I can apply rotation to 1 or 2 and get different results. Alright, so on rotation level 2, I can do all 4 levels of rotation. On rotation level 1, I just have the regular and the 180. And if it's not 1 or 2, just set it to 0. That way it never screws stuff up. Alright, now what we should see should be different because it should only be applying 2 types of rotations instead of 4. Aha! Alright, so what I want to do now is track down an elbow. I don't see any elbows actually. I see T-shapes. I see that pattern there. Alright, well let me go simplify the pattern real quick. I'll take out these artifacts. I'm going to take out this hidden passageway. And I'm going to take out this treasure. And I'm also going to take out the T's so that there's only elbows. Alright, so I should see elbows that look like this and like this. Can you guys see me, by the way? I feel like it's getting dark already. Hold on. Yeah, it's kind of dark. Okay, that's better. Alright, there we go. Yes, you can see I've only got those two types of elbows, it looks like. Actually, I still have a T-shape right there. What? Oh, I do have a T-shape in there still. There and there. That explains this here, because that's actually a T-shape with that, and that's a T-shape there. Interesting. But as far as elbows go, I only have an elbow that looks like this. I'm sorry, an elbow that looks like this? No, hold on. You guys see this is going down into your right. So like that is correct. Yep, that's it. So that one and that one show up right here and right here. And another elbow shows up right here of the same kind. But I don't see any other. Oh, here's another one of this kind. That's crazy that there's two of each elbow exactly. Awesome, kind of. I guess that's an elbow right there, but that's also the right kind. So yeah, we only have 180-degree rotations, it would appear to me, if that's all we've got here. So now, let's go down to where we've got the Wave 2D image processing params. Yes. If I set that back to a 2, I should get back to the original pattern, because then it should be applying all 4 rotations the same way it did before, and so the samples will be in the same basic shape. Oh, but I did edit the pattern, so the sample pattern, so it's different anyway. But if I see all 4 elbow types, I see one there and one there. That's that one again. Oh, here's the other two. So here we go. We got one elbow there, one elbow there, one elbow there, and one elbow there. So we got all 4 elbow types, which means to me that this is working. So that's good news. And then, we need to add in the mirroring. So let me take all of those out, and I would like to add mirroring params. There we go. Alright, so if mirror equals 1, then apply mirroring will equal 1. Alright, if mirror equals 2, I'm going to call that mirror type, then we still multiply by 2, but we set mirroring to 2. Pop up there to where it says mirror, make that a uint32 type. uint32 apply mirroring. Alright, so now I need a function kind of like this one. Wave 2D rotated sample to sampleBlit. I want a static void wave 2D mirrored sample to sampleBlit. And it'll look something like that. Mirror type, output. Okay. Wait a minute, what the hell was that? Oh, that didn't update the preferred X. Alright, 1 minute. That's a 4-coder bug. Scope. Alright, so sorry for this detour, just gotta quickly fix this 4-coder bug. When you move the cursor, please update the preferred X in the future. Okay. Stupid broken implementation of useful thing that I wrote my own self. Alright, there we go. Doopy-doo, doopy-doo, doopy-doo. Hey, Power C9K. Hello. Okay. So a mirrored sample-to-sample blit always mirrors it either horizontally or vertically. If it's got a even number on the horizontal mirror, it will be false, so not horizontal. No, that should be vertical. That's what I was originally trying to fix. Vertical. So if vertical mirror is if that is 0, then I want to do a horizontal mirror. A horizontal mirror takes every X and puts it on the other end. So that just needs to look something like this with the lines going backwards. So we have a source line and a dest line. Yeah. Then I'm going to take that dest line and I'm going to do that plus the width minus 1. And then at each step I subtract 1 from the destination. That way at each step what's actually happening, and you know what I could do is take that width minus 1 and apply it right here. And then at each step I've got the nx and I'm just stepping backwards through it. And of course by W what I mean to say is output W. Okay. And then same basic idea a second time, only now the X's do go in order, but it's in fact the Y's that go out of order. That means at each step I am subtracting by the width of the sample, and at the beginning I start at output height minus 1 times output with. Now neither of these could be memcopy, so just forget that nonsense. Although there's still probably a faster way to do them. Yeah, cool. Alright, so we've got that. Now let me go down to Wave 2D rotated sample to sample blit. Perform mirroring. If params.apply mirroring, then what I'm going to do is same basic idea. Grab the total count as it stands right now. Grab the no, I don't need any of that. Okay, so then grab this for loop here. And we don't need a rotation index or any of this nonsense really. What we need is actually we don't even need the for loop. I take that back. What we need is just to start where we left off. For each sample, yeah. Brett Hudson is asking me whether he may ask a question about my PNG implementation, and the answer is he may. I'll explain to everyone who's watching this who didn't see me and him chatting earlier, because it wasn't recorded. If I am recording, if the recording is working, then it wasn't recorded. Otherwise it'll be in the VOD anyway. But him and I were discussing how I've got a site builder that is a very basic thing that builds my 4Coder information website, sort of the HTML pages, and it packages all the images as well that sort of go into the directory that become the site. And I was hoping to, in my site baker, to build a thing that automatically does the resizing there, so that the images that are actually hosted on the site are the size that they will be at when they're shown on the screen, so that I'm not sending down big full screen images to users who then have to like handle all that bandwidth. Not that it's a huge amount of bandwidth; it just seems silly to me when I could, just save the world the pain of moving some extra bits around the internet. So I want to make a baker that resizes those automatically for me. And what I'm doing so far is I have STB image and STB image resize, which are able to open up PNGs and resize them, but I didn't see a way to save a PNG with those libraries. If there is a way to do it, then I missed it. And yeah, so Brett can ask me any question now, because everyone's caught up. Ah, there's another library in STB called STB Image Write. That sounds like the thing I need. Let's take a quick detour and look at that, because we might want a PNG reading and writing and resizing for this project in the not too distant future, so that we can start seeing these in more pretty outputs anyway. So let's take a look. STB Image Write. Let's take a look. Yep, it does exist. I'll put it over here so you can see. What do we got here? Looks like the right thing. For writing images to C-standard I/O, it could be adapted to write to memory or a general streaming interface. Let me know. I see. So it doesn't do as much compression as it could on the PNG, and it writes straight to standard I/O, STDIO, rather than to memory or to an output stream, it sounds like. But it looks like right here you can just give it a file name. Comp stride and bytes, and it'll just save that for you. That's what it looks like. Looks like the write to memory exists, actually. A little bit odd. Maybe they haven't updated the comments yet. Maybe Sean hasn't updated the comments yet, I should say. Yeah, this looks like exactly what I would want it to be. The comp there, what is that though? That doesn't get used till here. Well, let's go look at 2mem. Here we go. STBI write PNG to mem, and n is what? Oh, always with these crazy tables that I can't make any sense of. Yep. Here it is. Stride in bytes is x times n. Okay, yeah, so I think that's the number of bytes per pixel. It doesn't really have any comments on these functions to explain it at all. Alright, yeah, cool. I'll take a look at that for my SiteBaker. Thank you. Alright, even if it's only half the size of the smallest possible PNG, that's still smaller than what I'm sending, probably. I'll have to double check that. I want to make sure the memory actually is getting saved, or the whole point is lost. Anyway, getting back to this for now. Sample to sample blit. I give you the prev sample. I tell you whether or not to do a vertical mirroring. So to do that, I'm going to give you the apply mirroring, the current sample, the window width, the window height. You check the new sample, and then you put it where it needs to go. Perfect. Now, am I applying mirroring? Extract samples from image. Please apply, that's vertical mirroring. Please apply horizontal mirroring. Alright, so I started with that as my elbow type, but I've added that, which is actually showing up right here, which is interesting. That looks like it's working. Again, that type of elbow. That's a T right there. I don't see any of the original elbow type, actually. I see T's there and there and there. I see a T here. There's the elbow. Straight line. T-shape. T-shape. T-shape, T-shape, T-shape. T-shape. Yeah, just those two elbows. But those are both mirrored, no doubt about that. Let's try the other mirroring. Vertical mirroring this time. So now we have this elbow and this elbow that's the vertical mirror of it. So that's cool. Okay. So now we have mirroring enabled and different levels of rotation enabled. Okay, and that's only about giving us a half hour into this stream today. So now what I got to do is come up with the right thing to do next. There's a couple possibilities. One thing is the original C# version also had a thing that did tiling, and I roughly understand how that worked, but thinking about it more, I realized it must have had non-square sample sizes, and I don't know if I support non-square sample sizes correctly, because everywhere right now that I'm testing I've always used square sample sizes, and I know for sure that rotation breaks down a little bit when I switch to non-square sample sizes, so I'd have to be careful there. But what I want to do is go look at some of that C# stuff and see if how they solved it and think about that problem for a little bit. Now, I was thinking earlier today that possibly in the future an interesting experiment to run would be to just allow more than one sample size, period. So you have windows that are 2x3s and other windows that are 3x2s, and they just work together, and each cell is still picking one sample, and when that cell picks a sample, it always chooses a value for itself, and it also happens to require other cells nearby to take on certain sample values, but it restricts the neighboring sample values that are possible. But since you have these different sample shapes, which sample you choose would sort of determine what the influence is. So I don't know if that would break things down or if it would hold up just fine. Because you could imagine that being kind of interesting, where like maybe you want to capture both small and long range patterns. So you have simultaneously some large sample windows that you draw from and some smaller ones that you draw from, and that way sometimes you get things that exactly match large portions of your input, but sometimes you have things that are a little bit they differ on a smaller, finer grain, and they would all kind of just get mashed together, which is a neat possibility if it doesn't break down the whole system. So I want to look at that someday. But for now, I want to see how they handled that on the C# one. Let's see if I can find it. Wave function collapse. Yep, this is the one. So that's fine. Okay, here we go. Okay, so um, all right, never mind. I was just sitting here thinking about this symmetry thing, and I was playing with something similar earlier today, so it distracted me. But looking at these tiles, what I understand them as doing is um, there's with this system, it's enough to enumerate pairs of adjacent tiles only up to symmetry, which makes lists of adjacencies for tile sets with many symmetrical tiles. Okay, I can't really get from that what I'm looking for, so simple tiled model. Width, height. Here they're using lambdas to confuse the hell out of me, I assume. So, so the width and height, what is that? What is that even being used as? Here you're enumerating all of the rotations and mirrored rotations, I assume, into an array where fascinating. Yeah, it's a bit confusing. Not sure what's going on there. I mean, I get up to here. It looks like it's doing every rotation and flip pot combination for that. Yeah, I don't really feel like reading all this. There's another option, which is for me to find that YouTube video of this, because they listed the window sizes there. Here it is. Alright, I'm looking for, there's an n equals 3 sample. Does seem like all of their samples must be squares if that's how they're categorizing it. Let's see. I missed the part I cared about. Back it up, back it up. N equals 3 again. I want to see, I'm sure these are all n equals 3, I'm sure. Wait, what was that there? It's a fascinating one. N equals 2. Fine, very well. Don't care about this one. Don't care. What was that? Another n equals 3. Okay. Still don't care. Oh, I always liked this one because here it's doing a one-dimensional. You can get the system to simulate one-dimensional cellular automaton. You could actually, at a higher, if you have a three-dimensional system, you could get it to simulate two-dimensional cellular automaton. There, it did a rotation. Just double checking. Alright, get to the tiling. Here it is. Here's where the tiling starts up, I guess. I think so. Yeah, how does that work? Is that the sample? Or... No, right? It's generating samples from that, isn't it? Because it's looking at this and going, alright, so this here can touch there and there. This can touch here and here. With any rotation of this, it's the same. And let's see. This can touch there, there, and there. With this rotation, it can touch there and there. With the horizontal, it can touch there and there. You'd have to, all you'd have to do is specify that this thing here could touch that there, I think, because if it knew that... Yeah, I'm not totally clear on those rules. I'll have to think about this some more on my own. But man, isn't it just making samples of things that can go be neighbors to each other? 1x2 samples and 2x1 samples? Or is it making 2x2 samples and generating every combination of possible 2x2 samples? I'm not sure. That seems like a lot of samples, because there's, you know, 4 different ways to rotate that L shape. And there's 4 different ways to manipulate the... Well, there's 2 ways to do that, so that's 8, 16, 17... No, 8... And there's 4, 8, 9. There's 9 total possible values, and making every possible 2x2 sample there wouldn't quite be 9 to the 4, but it would be high. It's a lot of samples, so I'm not sure. Don't know. Yeah. Alright, so I think I need to figure that out before I keep going on. So let's go down here and read about this. The tile map generation. Okay, here it is, 1x2. If we simplify it even further by storing not the probabilities of pairs of colors, but the probabilities of colors themselves, we get what we call a simple tiled map model. The propagation phase in this model is just adjacency constraint propagation. It's convenient to initialize the simple tiled model with a list of tiles and their adjacency data. Adjacency data can be viewed as a large set of very small samples rather than a sample bitmap. So yeah, it is doing 1x2 samples. Does that mean it also has 2x1 samples? It seems like it must. Right? It has to know its vertical and horizontal adjacency rules. So I guess that is saying that there is such a thing as some samples being 1x2 and others being 2x1. If that's true, alright, so it's going through here, left, not split, new character. idea what any of that means. Um, tiles. I can't read any of this. What does this mean? Tiles add tile, and then it looks like a lambda that takes in an XY and gets the pixel of that, so yeah, no idea. I guess it's getting the XY out of this bitmap and adding that as a sample? That can't be added as a sample though, so that's added as one of the tiles, and then I don't know. What does propagation look like? If not periodic. I've got an idea. I guess it wouldn't really... I think I'll just assume that we can do something a little... It looks to me like this is doing a special propagation rule, whereas I wasn't really planning on writing a new propagation rule for this sub-case. I guess you could write a propagation rule that would be faster if you optimized it for this particular purpose. Let me see. If x2 equals 0, if not... if x2 equals 0, if it's not periodic, continue if x equals 1, x1 equals x2 minus 1, else if d equals blah 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 blah. Figure out some values for x and y, x1 and y1 and x2 and y2, and if there's no changes to x1, y1, you then continue. Not sure what x1, y1 is representing. First it's equal to x2, y2. Oh, you're doing d equals 0, 1, 2, 3. You're doing different rotations of the 2 by 1 adjacency thing. So which direction do we care about? I see. Yep, so this is just a specialized propagation rule for sort of 2 by 1 sample situation that's highly specialized. I see, I see. Okay, so that means multiple sample sizes should be supported, I think. And now I want to think about how to do that for the rest of the day. Because once I have multiple sample sizes, then we can do optimizations, because I'll have all the features necessary to match everything that that thing can do. Okay, so the first thing to do is to get a non-square sample size tested. So I have rotations turned off. I'm going to turn on one level of rotation and one level of mirroring. The advantage to having both of those is that if I have an elbow like this, if I rotate it by 180 degrees, I get this, right? So that gives me these two. And then whether I mirror that horizontally or vertically, in this case I'm mirroring it vertically, I get the other elbow types. So without ever having to do a 90-degree rotation, which doesn't really work when you're not in a square, you can still get all of the elbow types represented in your samples. And that's kind of a nice property. And later on I'll allow for full on rotation, but that will require that I have mixed sample sizes. At least I have to be able to support 2x3s and 3x2s, or 1x2s and 2x1s, and so on. If I want full-on mixed, it'd probably be even more work, because I'd probably want to sort them by their sizes, or label them by their sizes, or something like that, that I'm not doing right now. So, for now I'm just going to assume they're all the same size, and do 180-degree rotations, and then vertical flips. And then, where is, so there's my sample size of 3x3. I'm going to try to make that 3x2. So I have an x of 3 still, but a y of 2. And that should still build, I think. So let's see if that still runs. Now it's failing. So now I'm going to open up the debug stuff. That's a 3x3 region that you reached a contradiction on, which is kind of odd. But first I want to look in, yeah, look at, these are all 3x3 samples, man. None of those are 3x2s. Alright, hold on. Does 3x3 show up somewhere else? Oh, it does, look at that. Okay, so what I should do then is say, well, first of all, params window width sample window width equals 3 and height equals 2. Sample window width, sample window height, sample window width height. Still failing right away this time, but let's take a look. Okay, the samples don't look wrong to me, at least not at a glance. So why is it failing right away? Yada yada yada. Boom, bing. Boo-ba-doo-ba-doo. Coefficient count is 27,900. That's pretty good. Pretty good coefficient count. Okay. Blah blah blah. Oh shit. It's not what I wanted. Get me back to there. There we go. Alright. No failure there. So we set that one to 1. We set all the other ones to 0. By the way, which one is sample number 15? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I see. So you're putting down a 0, 0, 0, 1, 0, 0 situation. You're saying, like, I've added a change at 0, 0. That succeeded. Good. Then you go in here to propagate. You find the change 0, 0 has just occurred. Pop that off. And delta x, sample width, sample width, sample height, sample height. So delta x starts at -2, and that's going to go all the way till 2. This starts at -1, and it's going to go all the way to +1. -1, 0, +1. Yeah, makes sense. So cell 1 has changed, and we're propagating that to cell 2. We grab both cells, which are just coefficient arrays, and we ask, did cell 2 have to change because of this propagation step? And we go, alright, well, here's min x and min y. Max x went to 1, so yeah, makes sense. Min y is less than max y is greater than, yeah, so that becomes that. Perfect. So now it's just the top left corners that are getting compared to the bottom right corner of a different cell. And we come in here and we go, okay, well, T2 is the sample for the second cell. If cell 2 still supports that sample, we ask, can that sample coexist with the original? And then we just look for a sample that we can use. You know what I should do for an optimization? Well, in the meantime, 0 does not equal x plus 2 plus 1 times sample height. That's wrong. That should be sample width as well. Okay. Found a bug. And you see, as long as those sample width and sample height were equal, that bug was never going to show itself. Now what I should do here is say, to do keep a list of uneliminated sample values for each cell. So each cell will have an array of true falses and an array of which, sort of, so you have both the best of both worlds. And whenever you eliminate one from the things I have not yet eliminated, you'll just pop somebody from the end of the array into the middle. That takes one time and set it to 0 in the true false array. That way you have the ability to quickly iterate all of the existing cells simultaneously, as asking, is this cell got this particular sample available still, of one time. And it just means each cell takes twice as much memory. Hey, what was that? Hey, ho ho ho! That was the only bug, and now it's working. And you can see that with that sample size, this is like wildly interesting here. Since it doesn't capture as much long-range information, it now believes that dead ends are allowed again, because it, like right here, that let me see if I can demonstrate. So like this here is 3 zeros below 3 ones. So if we look around, somewhere that should be a sample. 3 zeros above 3 ones. 3 zeros below 3 ones, right? So it thinks that's a relevant sample. And that's true because you can imagine any corridor that I have, or even the side of a building, the side of a room, will look like this. Now let's track down 3 ones on top and then 1 1 on the right. Let's see. Right here. Right? So that is the sample right next to the first one. And again, even though there's no dead ends, that could totally exist just because there's a corner here, and in the real full sample this goes down further, but it doesn't see that in a 3x2 sample. And then we want one where there's just a 0 in the bottom left corner. Um, there's one. There's one. Ah, here it is. So you can see again, it could think, well, that's not a dead end. There's going to be more down here. But then when somebody else comes along to fill in the bottom portion of that hallway, it thinks, ah, well, that could just be this sample. And so it turns into a dead end, even though the sample input didn't have any dead ends. So it's picking up on all of the features that occur in 2x3 blocks, but you can't see in a 2x3 block the existence of dead ends. At least you can't see the existence or lack thereof of dead ends in horizontal pathways. You will notice, however, that in vertical pathways we don't see any of those, and that's, I'm presuming, because of the shape of the sample we took. I bet if I switch it to a 2x3, we can probably get vertical dead ends and not horizontal ones. Yeah, see? Now we're getting vertical hallways that have dead ends and not horizontal dead ends. Fascinating. And that's because a dead end basically looks like a dead end because you don't know that, say like you've got a vertical path here, since this is only 2 wide, you don't see that there's actually more to the right that makes this, that forces this to keep going that way, right? Now I wonder, what if we play this the other way? What kind of results do we get? The larger your sample size, the more memory it takes and the more time it takes to do propagation, because when I decide a sample here, that affects samples farther away. But now this is picking up on longer range features than it did before. It also has this interesting opinion of this 2x3 block existing just in the middle of nowhere, which I guess is not unreasonable because that's just combining this with, let's see, that with that and that, no, not that, that for sure, and that, and that, and that, and that, right? You have enough things that you could see it thinking, alright, make a little 2x3 block. Well, it seems like that should be lower likelihood. It's making sort of long, tall vertical rooms. I bet that's, again, a feature of this shape of the window. But if I switch it, I can get long horizontal rooms. Yeah. Roughly speaking, it's not quite the same. But neato. Alright, so now it supports non-square samples. I'll have to take this one step further at some point and get it to support samples of this shape and that shape, right? 3x4 and 4x3, or 3x2 and 2x3, or 1x2 and 2x1. I've been at it for an hour and 18 minutes, so usually I go to 2 hours. Trying to think if there's anything I can do in the next 30 to 40 minutes that I can feasibly get done with on time. I could maybe play with passing in 2 sample sets simultaneously, because that would be the first step towards having multiple sizes if I wanted to keep on organizing them in the same way that I am now. Let me explain what I'm saying a little bit in a picture so that I can see it myself better and so you can see what I'm talking about. So right now what happens is this, do I have some kind of, like, wish there was whoops, that's not what I want. I wish there was a way to, like, scroll the size of my brush. Okay, so basically what I have is it's currently getting its sample inputs like this. Later, Brett. Oma Heath asks, is wave function collapse like quantum stuff? Yeah, it's a quantum mechanically inspired procedural generation algorithm. Basically, it has some sample inputs that tell it what sort of things exist in the world, what the world should look like, and then you give it a big empty space and tell me, all right, show me a big picture of, like, generate a world for me. And it generates a world that has features that match the smaller input sample image that you gave it. So like, I'll give an example. This is the world it generated when I gave it 3x4 window size, which is what I was playing with today, which is getting non-square window sizes. And if I go up to the base image here, this here with these zeros and ones, if you can sort of make out what that the shape of that room is, it's here's a big room right here, here's a pathway, and it imagines that that loops around there, and here's a pathway that loops around there, and here's a T-shaped corridor and a turned corridor and another T-shaped corridor, and then it looks at that smaller sample and generates this bigger one with similar features to the original, is the idea. Okay, so what's going on right now is I have the process that we have the input image, right? Here it is. Doop, 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 right? Input image. And then I have my sample set, which is all of the samples that I pull out of that, which are small little windows like this. Doop, 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 doop. And each of those comes with a weight attached. So weight, 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 weight. Omahip asks, so almost like a Markov chain sort of thing. I'll be honest, I don't know what Markov chain means. I mean, I know what it roughly means, which is that you have a simulation of some sort where the next state is reliant on previous states, but I don't know how that makes any sense. Like, that's what all simulations are. I don't know what makes something Markov or not, so I can't really answer that question. I've never heard a good enough description of what Markov means to really understand it. Properly. Okay, so we got these little samples here, and I have one big set of little samples with weights, and that big set comes with a little bit of extra information. It comes with a width and a height, and let's see what else it comes with. Samples, let's see, a width and a height and a count, and that's it. Okay, that's good news. And the issue that I see here is um, if I move the width and height, if I want to change width and height, like have some samples that have one width and height and another sample that has a different width and height, I either have to move the width and height information into each sample, thus increasing the amount of memory I use and complicating like how I have to extract width height information all over the place, or I have to have another sample array over here that contains the other width heights, like this. Width height of a different width height, potentially same or different count, and then all the new samples. Dupe, 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 and doop-a-doop-a-doop-a-doo, and all of their own weights. Ah, shit, come on. Weight, 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 weight. Right? So, right now I have the thing that turns an image into one of these things. The question is, do I want to add a second one and feed both of these into the generator machine? So and that's the thing that poops out the output. If I try to do this, then what I need to change is this part would work the same way basically. Well, no, I have to change the generator to take this as an input instead of just one. So I would have to do a lot of work in here. And then the other thing I would have to change up is the way I generate these samples would get changed quite a bit, or at least partially, because I'd have to count out how many of each type I want instead of just counting out the ones I've got. Now if I bake the width and height in, I can make my life a little easier. The only problem is then I have to know a maximum size for every sample so that I know, alright, the stride of a sample is X, and some samples just don't use all of their memory. So each sample has like the first thing in that sample is a width, the second thing is a height, and then after those first 8 bytes, everything after that is the sample. And each sample would need to be the same length in bytes, which means I would have to waste a lot of memory, but it would maybe be, I don't know what's the word, somehow more manageable, potentially. I think I should go for that actually, I'm not sure. Well, depending on which one I go for, it will change how I call into the system. So let me take a look here. Let's suppose I'm doing 3x2 samples, or yeah, 3x2 samples, and here I'm saying, look, I'm going to have some processing parameters. Here's the width and the height, and I want to apply rotation level 2, and so it'll have to look at that and determine, we're going to need, after rotation, that width and height is going to be different if I rotate by 90 degrees. So I'm going to need 2 sample sets, and the maximum size for each sample set is going to end up being the same. There's also this question of, do you pull samples out? If I do it this way, there's also the question of, do I pull out samples? Because, right, when I go here and I'm doing this, if I pull out a 3x2 sample and then apply rotations, that's different from pulling out a 3x2 sample and pulling out a 2x3 sample, right? Because then I still might never see this feature right here. right? Um, so, yeah, I think even if I allow the sample arrays to um, have varying widths and heights inside them, I still probably want to be able to feed in more than one sample array into the generator anyway. So I'm going to do that first. And then if we want to, we can make the width and height heterogeneousness vary by sample array. Okay. So let's take a look at what that's going to take. I pass in a wave to the samples struct. Samples. Yeah. Okay. So let's see. I assume that I'm just everywhere treating samples as samples, sample array. Why am I not using sample array down here? Well, I shouldn't switch to using that. I'm actually going to eliminate it. So I'm going to start eliminating things that I have to pre-bake for a single sample type. Weight pointer equals sample array. Yeah, so that should actually be samples 0.weight. Sample array. Brilliant. Okay. So that gets me one little tiny baby step closer. Now the problem is, if you look at this, it's going to sample count. I don't like this situation for a lot of reasons. I'm going to have to think. No, I think I should do this. I think I should. I might end up doing both, supporting both ways and testing which one's actually better. Because there's too many unknowns about what might be better or not, so I just don't know. Samples. Sample count. State has sample count in it. What is state? I see. Okay, so that gives me a sample count for each, a total sample count across all of my sample arrays. And then I can, let's see, width and height, what are those? Oh, that's the output width and height. Okay, I'm going to call that output width and height. One second, I need to go get a water. Okay, so let's see. Okay, so the goal here, weight by log weight. What is that? Got it. Okay. So, um, size of wave 2D sample. And then this here is going to be a loop across sample array count plus I, and then you grab sample arrays I, by the way, this is broken down in the wrong way. Okay, so we grab the weight pointer and we start going along. But the only thing we want to make sure that we're doing correctly here is Just renaming variables right now, people. Nothing interesting here. Doopy doopy doo. Doopy doo doopy 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 doo. Doopy doopy doo. Doopy doo doopy 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 doo. Doopy doopy doo. Doopy doo. Doop doop doopy doopy doo. Doopy doopy doo. Doopy doo. Doopy 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 doo. Doopy doopy doo. Doopy doo doopy 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 doo. Doopy doopy doo. Doopy doo. Doopy 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 doo. Alright, perfect. No change. Except for that change. I see. Let's put this back to a 3x4 situation, just so I can make sure there is no change. There was change. Alright, back it up, hold on. What went wrong here? Fascinating. What? Oh, I have a higher level of rotation than I'm allowed to have here. There we go. Alright, so wave 2D set the output size. Goes right there. 2D split this as stated in the previously deleted comment. Use your own memory. Here we go again. Doopy doopy doo. Doopy. Oop, shit. Doopy doo. Doopy 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 doo. Doopy doopy doo. Doopy doo doopy 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 doo. Doopy doopy doo. Doopy doo doopy 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 doo. Doopy doopy doo. Doopy doo doopy 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 doo. Doopy doopy doo doopy doopy doo. Doopy 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 doo. Skipped one. Doopy doopy doo. Doopy doo. Doopy 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 doo. Doopy doopy doo. Doopy doo doopy 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 doo. Missed one. Shit. Those ones weren't wrong. Perfect. Do you know that that right there looks exactly like the original image? Like it's exactly the same shape. It's crazy. This is different though. And actually this T shape here is different, but man, that's crazy. It's awesome. Alright, so that gets me just a one step there. Let me go to Wave 2D set output size real quick because I want to fix up some crap in there. This isn't so much about setting the output size, is it? It's more like initializing the state. I could call this initialize state, and that might be better. I'm passing the sample arrays in here, and then I pass the samples again. Wave 2D generate output. I pass the samples in again. That's kind of weird. I think what I should actually do is say the samples, once you've initialized the state, get tied to it because it processes this information too. And then what we'll actually do is instead of setting output size, we're going to say initialize state. Hello again, Power C9K. Okay, so then what I want to do is right in here, samples arrays, uint32 sample array count. Power C9K is asking me what I plan to use this program on, and the answer is I don't really have a use case in particular because I'm not working on a roguelike or anything like that where I think it would make a lot of sense to maybe have some generative procedural generation tools at my disposal. So it's really just kind of my practice right now. I'm going to use it later on once I've done having all the features that the original had. I'm going to try to make it run as extremely fast as I possibly can, just kind of for practice and fun. So yeah, no really point to it. Unless I ever do make a game where I want to generate stuff. Or like for speedy level editing, like if you just want to edit, like make a level editor where you just put in a few details and then you're like, alright, fill in the rest of the tiling and it just does for you. You could use something like this. Yeah, you could totally use this as the basis for making a really interesting roguelike map generator, and then you just have to do a little bit of fix up on it after you've done the generation. Like, this system doesn't let you do anything like guarantee that all rooms connect to each other by hallways, so you'd have to do a little bit of a fancy sort of, alright, once we've generated it, flood fill each room and make sure that you can connect it to other rooms. If you find two independent cells that don't connect, then draw in your own path manually that connects them and stuff like that, or have other ways to connect them. You know, you have to, and like if you want to have like each room should only have one stair down or exactly 3 stairs down or whatever the rule is. You have to put that stuff in yourself because it doesn't really do global rules very well. It's about taking local features and matching them up, but it also means you can have a very fun sort of generator where to make new level types you just give it new sample inputs and tweak the parameters, and then it generates whole new looking level rules, and then you just have to apply your sort of global rules after the generation is done. But to make it useful for that, you would want to start by, it's also, if you're working with an artist, by the way, it's probably a really useful way of helping them have direct input on how the map generator works, because otherwise the map generator is just some code that only the coders really have power over. But with this lets an artist sort of draw what they think a map should sort of generally look like and put that in as the sample input, and then see what kind of maps they get out, which is really interesting. So that was actually the initial reason I took an interest in it. But first it's got to be a lot faster than it is now so that it's a quick generation process. Okay, so cool. So before we wrap this up, I want to change that to initializing the state, and I want the state to hold the sample array coefficient count. I see. The sample array goes there. The sample array count goes there. Alright, still working, so cool. That's about all the time I've got for today. If you join me next week will probably be my last stream of the year, and I don't know if I'll resume streaming after that. Actually, I might just make offline videos and upload them to YouTube. And the reason for that is I'm going to be setting up in a new office area, and I don't think I will have internet in that. I don't think I will buy internet for that office. So at least not good streaming internet for this computer. I might just have Wi-Fi for my laptop. I don't feel like getting the internet set up for this computer with a Wi-Fi card and trying to install an Ethernet or whatever, right? So that means next week might in fact be my last stream for a while. So if you join me next week, I'll continue working on this project here. And I'll try to get the multiple sample sizes working. So, see you guys then. Bye-bye.